This video will deal with arithmetic operations with arrays, which are so much like vectors. I'm going to jump right into the MATLAB here. Not do much board work, I don't think. So I'm going to run this, and if you see, I'm going to define an array B of ones, 2 by 6 of ones. C is a 2 by 6 of 3. Excuse me, 2 by 3 of ones up on B. 2 by 3 of threes in C. A 2 by 3 array A, and a 2 by 3 array D. D is the sum. So we're going to build off array A here and use B and C as we go forward. So on line 11 on D, I'm doing addition, and so D is equal to A plus 2. Once again, our rule is either they have to be arrays, both arrays have to be the same dimensions, or one has to be a scalar. And so here I'm adding a scalar value 2 to array A. So if you look here, the values of array A have been incremented up by 2 in all the values in D. So 2 has become 4, A has become 10, and so on and so forth. So this is a element by element wise addition. Comment that out. Look at what happens when we do E. So E, I'm adding array A and array B. Once again, they are the same size. And so if I add A and B, B is just going to take all the values in A and add a 1 to it. So you see E has is A with everything incremented by 1. So that's addition. Go down here and do subtraction, which follows suit. Now we have A subtracting 2. This is with a scalar. So you see F has the proper values in it. Subtracting an array from an array is G. So I'm subtracting array B from array A. Once again, they're the same size, same dimensions, so it's okay. If they were not the same dimensions, we would get an error. Okay. Down here on line 15, look at H, it's multiplication. I'm multiplying with a scalar, so I do not need the dot. Okay. And so everything inside of A gets just got multiplied by 2 in array H. And so comment that out, come down to line 16. Now I'm multiplying 2 arrays together, so therefore I must put the dot in there in order to get element by element multiplication instead of matrix multiplication, which we're not doing matrix, we have arrays. This is one of the reasons why we at least by nomenclature, delineate between an array and a matrix. So we're doing array multiplication, which is element by element multiplication. So therefore we do need this dot here before the multiplication sign. And so I equals the product of C and A. So you see everything in A has been multiplied by 3. Oops. Same thing holds true down here with division. Is that because I'm dividing by a scalar here on line 17, I do not need the dot. I could put it in there just as well as I could have put it in on line 15 with scalar multiplication, but I chose not to do it here just for illustration. So line 17 yields vector J, which is when you divide A by 2, you get these values. Line 18 does division, but it is array division, dividing one array by another, so we need the dot here. If not, it would try to do matrix division, and we don't want that. So K, you wind up with these values here from the division. And so you're dividing A by C. Once again, they're the same size, so this works fine. On line 19, I'm going to get an error. And the reason I'm going to get an error is, if you think about it, I'm doing exponentials, right? And so if here I'm saying square the vector, square the array A. Well, if you're squaring it, that's multiplying A times A. And so let me go to the board here briefly. So if I have the array 2, 5, 7, 8, 4, 9, and I square it, I'm multiplying it by itself. So I'm actually doing this. And in doing that, now I've gotten into a matrix multiplication situation. And in order to do that, remember, this one has 2 rows by 3 columns. This one is 2 rows by 3 columns. And these two should equal, and they don't. So that's why I'm getting an error. Okay, so remember, in exponentials, it's like multiplying an array by itself. And so therefore, I'm going to need the dot if I want to do an element by element. Even though this value 2 is a scalar here, it is saying multiply a by itself, and the dimensions are not correct for that. So that's why I get an error there. So I come back, and if I want to do, if I want to square everything, if I want to do an array operation and square everything inside that array, then I have to use the dot. I have to use the dot with the caret or the exclamation sign, excuse me, the exponent sign, because that will do an element by element squaring, and each element inside the array gets squared. And so you see that here in array M. And then lastly here, if I want to raise everything in A to its corresponding power in array C, I can do a dot with the what they call a caret, or the dot with the exponent symbol with the C as well. And so I wind up with array N on line 21. So it works very similar to the vectors. Just be mindful of the dot so that you're doing element by element operations, not matrix operations. And then with the exponent, you have to, if you want to do array operations, you need the dot with the exponent symbol.